Welcome to the second in the series of 4 webinars on the Catalyst project. My name is John Booth and I'm the project leader for Green IT Amsterdam, and I'll be your host for the entire series. Our project coordinator has recorded an introduction and overview to the project, and we'll start with that in a moment, followed by our colleagues from engineering, Marzia, who worked as a software analyst in the R&D department of engineering from Italy. And in the context of the Catalyst project, she has been mainly involved in the design of the Catalyst framework architecture and in the design of the Catalyst marketplace. And then we'll have Artemis from Power Operations Limited from the UK with another pre-recorded video on the data center Catalyst marketplace. And we'll close with some questions after that video. Okay, so without further ado, let's have a look at this project overview.
Hi, I'm Diego Arnone. I'm a project manager and I'm a senior member of the Research and Development Laboratory of the Engineering Group. And in the role of coordinator of the Catalyst project, I'm going to give you a bird's eye view of this research initiative co-funded by the H2020 Framework Program. This introduction explains at a very high level what the project has developed and what kind of benefits it aims to achieve. Let's start from a proposal. Well, we are in the context of data centers connected to more commodity networks like power grid, data networks, district heating. The proposed idea is that data centers can and should offer energy flexibility services to their smart grid and district heating networks. So data centers should not be considered as only as energy consumers, but as active players that are able to sell their intrinsic flexibility. This is the identity card of the project. We have close to 3 million euros assigned to a consortium of 10 partners based in 6 European countries. 3 of them are industrial partners, the coordinator engineering, Singular Logic and Schubert Phyllis. 2 are small medium enterprises, PowerOps and Carnot. 2 are research institutes, PSNC in Poland and University of Cluj-Napoca in Romania. 2 are utilities, NLX and Oleander. We have 4 data centers that are our workbench for the validation. In the Catalyst vision, data centers are to be intended as multi-carrier hubs that work at the crossroad of more networks, energy networks and data networks. And these hubs can exploit and manage their intrinsic redundancy to provide flexibility, to deliver system-level multi-carrier flexibility services. The consequent new revenue streams can allow them to invest in energy efficiency and in reducing data centers' environmental footprint. This figure depicts the concept of the project. A data center, thanks to an innovative resource management and optimization system, is able to sell flexibility to the local DSO, the distribution system operator, by putting offers on a local balancing marketplace in order to sell or buy energy, both electricity and heat, in another marketplace, or to move IT workload from a data center to another federated one. We must think that a data center consumes energy to supply servers that execute workload and generate waste heat. So power, heat, IT workload are strictly linked to each other in a data center. These commodities can be traded in a multi-flavor coupled marketplace that Catalyst proposes as a service. The flavors are electric flexibility, electricity, then energy, heat, IT workload. And this picture shows how a data center stays in the middle. So, in conclusion, electricity, heat, and IT workload are considered as commodities that can be traded, exchanged, transferred in their corresponding emerging markets, either individually or combined to achieve synergies whenever possible. In order to achieve its own objectives, Catalyst has not started from scratch, but this project has merged, evolved, extended, and also integrated the results coming from Geyser and Dolphin, two FP7 research projects successfully completed by some of the partners involved in Catalyst. The new developed tools can utilize and trade the waste data center heat to lower the overall system level energy distribution footprint, reduce data center energy costs and create new data center incomes, can assess resiliency of energy supply and flexibility, trading off data center assets against local distributed RES, energy storage, and efficiency, can deliver energy flexibility services to the surrounding energy grids ecosystems, can also exploit migration of traceable ICT workload among federated data centers, matching the IT workload demands with time-varying on-site RES surplus availability or where heat generation is needed. This is the follow the energy approach. These tools have been developed to be adaptable to a variety of data centers categories. Different types, colocation, enterprise, HPC, different geographical location, different architecture, from large centralized to fully decentralized micro data centers. As already mentioned, Catalyst is validating the main results of the project in 4 different pilots. The green geothermal co-location data center in Pont Saint Martin in Italy, owned and managed by the engineering group, the coordinator of the project. HPC data center based in Poznan, Poland, partially supplied by renewable energy sources that is experimenting the reuse of waste heat by heating up a building of the nearby university campus. A fully distributed data center operated by Carnot, where servers are installed in different buildings as heaters. A co-location data center owned and managed by Schubert Phillips, integrated with a smart grid. They are experimenting the provision of electrical flexibility to the grid. There's also a legacy data center operated by Singular Logic, but used only for lab experimentation. Okay, this card shows the list of the core features of Catalyst that are being validated. So free air and water cooling, geothermal and passive water cooling connecting to the drinking water grid. The first one is tested in the engineering Pont Saint Martin data center. The second one in Schubert Phillips, the Netherlands, in collaboration with Oleander. waste heat regeneration via heat pumps, and reuse of smart thermal low temperature district heating networks. This is happening in Schubert-Phillips and Poznan. Also, space heating, cooling of co-location data center offices in favorable seasons. So, Ponza Martin co-location data center in Alpine climate area in Italy, but also Poznan and Schubert-Phillips. Smart waste heat reuse and preheating diesel engines and UPS systems. So, Schubert-Phillips, the Netherlands, and RES, basically photovoltaic panels, and DES, basically batteries, integration, and this in Poznan. Heat demand driven IT workload balancing in a fully distributed data center. This is the case of Carnot in France. Energy flexibility services via backup generator. So battery storage, UPS, and flexible workload adaptation of IT workload. And this is happening in Poznan and Schubert-Phillips. IT load balancing, targeting lowering of energy consumption and cooling needs between legacy commercial data centers belonging to different administrative domains, for example, singular logic, and green data centers, so engineering Ponza-Martin data center or Poznan. Last but not least, the value proposition. This nice picture shows the benefits for data centers because this technology reduces the operating costs for energy, is able to improve performance and creates new revenues by reusing waste heat and by providing flexibility services. The energy sector, because we have a better stability and security of supply, easy access to local flexibility services, accelerated heat reuse, but also for smart cities, especially by empowering energy prosumers and unlocking their flexibility potential. So, we need interested partners, people interested in this new idea of data center to be intended as active player in the smart energy infrastructure of the future. So become the catalyst to energy transition, support green data centers in Europe, join the Green Data Center Stakeholder Group. What you need to know is in our manifesto that can be downloaded from the website. And this is how you can join us. That's all from my side. I hope that this short introduction will be useful for a better understanding of all the tools that have been developed and will be explained in the followings. So, enjoy your webinar. Goodbye.
Thank you, Diego, for that overview of the project. And now on to the Catalyst Marketplace video. This is also a pre-recorded video. The video lasts for about 30 minutes. And when it's finished, we'll open the floor for some questions. So we'll continue with the Catalyst Marketplace. Thank you.
This presentation provides an overview of the vision, concept, and implementation of the Catalyst Marketplace. Today's and tomorrow's energy landscape are largely different from the past. Several drivers point towards a need for more energy system integration, such as the increased penetration of multi-carrier conversion technologies, the uptake of energy storage technologies, the increased uncertainty in electricity systems due to the integration of variable renewable energy sources, and the consequent need for extra flexibility to keep the electricity systems stable and safe. Furthermore, heat production from renewables and waste heat reuse can boost system flexibility and help with energy decarbonization. Although there is still no common interpretation of integration across different stakeholder shares, The Catalyst marketplace implements the vision of coupling the still decoupled IT and multi-carrier energy sectors and contributes towards full integration of prosumers with renewable energy sources, smart cities, smart grids, and smart district heating networks. This is achieved via an electronic marketplace providing not only data centers but also generic multi-asset participants with revenue streams in four innovative markets: the electricity marketplace, the flexibility marketplace, the heat marketplace, and the IT load marketplace. The marketplace has been conceived with two possible timeframe variants: day ahead and intraday. Day ahead is one day before the delivery, where producers and consumers may respectively sell and buy the commodity for the next day. Intraday is in the day of delivery, where producers and consumers may adjust their programs determined in the day-ahead marketplace. Each time variant is organized in a set of scheduled sessions. Within the time interval corresponding to the session duration, supply offers and demand bids can be placed. At the end of each session, the market is cleared based on the clearing mechanism adopted. The electricity marketplace is an exchange market open to prosumers and electricity aggregators, where electricity budgets are traded to satisfy energy demand with green electricity produced within the boundaries of a smart city or smart district, while minimizing energy transmission losses. The market is cleared using the market equilibrium approach, where the equilibrium price is the price of the good when the supply of it is equal to the demand for it in the market. Offers and bids consist mainly of pairs of values representing the quantity of price of electricity. Supply offers represent the willingness of a producer to sell a quantity of electricity not higher than the one stated and at a price not lower than the one stated. Demand bids represent the willingness of a consumer to purchase a quantity of electricity not higher than the one stated and at a price not higher than the one stated. Once ended the scheduled time, the session is closed and the market clearing process starts. All valid supply offers are ranked in increasing price order on an aggregated supply curve, and all valid demand bids are ranked in decreasing price order on an aggregated demand curve. The intersection of the two curves determines the market equilibrium, which gives the clearing price at which all accepted bids and offers are remunerated, and the overall quantity of energy traded in the session. Consequently, accepted bids and offers programs are identified. The acceptance of an offer or bid implies the market participant's commitment, respectively, to inject, withdraw the quantity of energy specified in the offer or in a bid in a prefixed time frame. The heat marketplace is an exchange market that allows heat budget trading while also demonstrating how waste heat reuse may become a new flexibility service, trading off additional investments for waste heat regeneration, for example heat pumps, with incremental revenues from waste heat valorization in a systemic framework. The marketplace is open to prosumers and heat brokers, which trades aggregated prosumers, offers and bids. The market equilibrium mechanism is adopted to clear the heat marketplace as described for the electricity marketplace. The flexibility marketplace allows prosumers and aggregators to offer flexibility budgets to support the electrical grid in cases of grid stability threats. The DSO is the unit buyer for the offers placed. The structure and duration of the market sessions must ensure that participating prosumers have enough time for being ready to deliver the flexibility service when requested. At the end of each session, the DSO selects the offers that could fit the needs of the electrical grid. After the DSO provides the feedback on the actual delivery of the flexibility services when requested, the market is cleared, pay as bid. The IT load marketplace allows IT load trading, acting like a translator between the energy and the IT world. Indeed, IT load exchanges, for example under a follow the energy approach, take place as a result of the need for shifting energy consumption in time. The marketplace enables market-based negotiations focused on trusted IT load exchanges among data centers belonging to different administrative domains and based on micro-contracts. The marketplace is structured in day-ahead and intraday variants. Each time variant is organized in a set of scheduled sessions where participating data centers provide their availability to move or accept specific IT loads. The structure and duration of the market sessions must ensure that participating data centers have enough time for being ready to exchange their IT load when needed. In this marketplace, contrary to their general meaning, an offer represents the intention to migrate some load, offering a price for accepting the load migrated that cannot be higher than the price included in the offer, while a bid represents the intention to accept a load and the minimum price accepted. The IT load market clearing is supported by the federated level of the Catalyst framework, which is able to find the optimal offers bids matching. After the closure of the session, based on the actual bids and offers placed on the IT load marketplace, the federated level applies the vector bin packing algorithm to identify which IT load can be relocated in which data center. This relocation algorithm optimizes hardware utilization and inter-federated data centers coordination, trying as much as possible to honor the energy constraints specified by each data center. The price at which the load will be exchanged between the two data centers involved is the median value of the price in the bid and the price in the offer. The Catalyst marketplace allows prosumers data centers, which are the main focus of the Catalyst project, sustaining investments in renewable energy resources, thermal energy storage, while adopting innovative solutions such as energy reuse, live migration, and heat demand-driven IT workload balancing. Moreover, Catalyst provides additional tools constructing data centers trust to such solutions, such as intemperable traceability of IT loads, flexible service level agreement management, and secure communications channels in inter-data center communications. The Catalyst marketplace variants may work as mono-carrier marketplaces or as multi-carriers marketplace, where the marketplace variants are orchestrated under correlation criteria. The multi-carriers marketplace favors prosumers taking the risk of playing simultaneously in parallel sessions of different marketplace variants. During the market session time frame, all the interested participants place bids or offers on parallel sessions in different marketplace variants and can bind some of them with constraints, for example, all or nothing strong constraint or at least one weak constraint. A priority is assigned to the participant on the basis of the number of markets correlated. When the clearing of the parallel sessions ends, the temporary market results are analyzed by the marketplace orchestrator, which checks all the constraints provided by the participants in their correlated actions. In case some constraints are violated, the related actions are removed from the list of bids or offers placed in the marketplace sessions, and the impacted marketplaces are cleared again. After the new clearing, all the constraints for the coupled orders are checked again, and this process continues until a stable situation is achieved. The Catalyst architecture includes a data center side part, the Catalyst DC Flex Manager, which is a set of components intended for optimizing the management of data center resources, but also ensuring data centers' interaction with the energy and cloud networks, as well as with the Cloud Federation services on the Catalyst IT Federator. Such services ensure optimized management of IT resources based on prior energy-aware optimization, migration of virtual loads, and are also responsible for such loads traceability. Lastly, the architecture includes the Catalyst Flex Change, implementing the Catalyst Marketplace, and homogenizing the design and delivery of services of diverse carrier marketplaces. Full integration with the Catalyst Marketplace is realized via automated participation, which is enacted via the marketplace connectors. Although Catalyst exploits those modules for the data center's cases, the marketplace connectors can be well exploited by entities in the role of the marketplace participant, such as DSOs, aggregators, in order to post bids and offers via programmatic calls. Indeed, the marketplace connectors expose APIs which allows consuming their services by third-party platforms, such as management services, decision support systems, building management systems, assuming that the relevant functionality is implemented on the other hand. Each variant is composed of the information broker, market clearing manager, and market billing manager components. The information broker provides data persistence and controlled access to the Catalyst marketplace data. The market clearing manager undertakes the clearing of each marketplace variant. Especially for the IT load marketplace variant, this component interacts with the IT load balancer server, which is responsible specifically for the IT load marketplace clearing. The market billing manager implements billing functionalities, such as generation of billing information and reports based on the clearing outcome so far provided by the market clearing manager. On top of the marketplace variant set, the Access Manager provides the user interface functionality of the current market deployment and thus provide access to the variant's functionalities. The set of the marketplace variants is orchestrated by the Multi-Energy Marketplace Orchestrator, which implements sector coupling among the variants of the current deployment, enabling combined market actions, bids, or offers to be considered within parallel market sessions of different carriers, as well as their coupled clearing. The Multi-Energy Marketplace Orchestrator provides the logic of multi-energy marketplace orchestration, as well as persistence and access to the data related to this orchestration. In more detail, it is responsible for starting a market session, ending a market session, starting and orchestrating the clearing phase for both the cases of mono marketplace and coupled marketplaces. The marketplace as a service concept in Catalyst allows automated pre-configured installation and operation of Catalyst marketplace deployments. A marketplace deployment is composed of a set of variants, at maximum being those four: the electricity marketplace, the flexibility marketplace, the heat marketplace, the IT load marketplace. The approach is flexible enough to allow the instantiation, deletion, and general administration of a single marketplace variant within Catalyst marketplace deployments. The number and type of marketplace variants may vary among deployments or may be changed at any time. An instantiation of the Catalyst Marketplace as a Service platform allows for the full cloudification of the Catalyst marketplaces in a fully cloud-native way, with all the benefits that such a concept bears. Ease of deployment, configuration, and maintenance through automation. Indeed, one can easily deploy via a few clicks a new marketplace variant instance in a certain region, the only settings required being related to the variant, the clearing mechanism, the region, and the market operator. The configuration of security aspects of the deployed marketplace variants, the access part, and the interconnection of the marketplace components are performed automatically. Hence, the configuration time is minimal and less error-prone. A typical variant installation takes less than 1 minute to complete. Single sign-on. All marketplace variants within a region are configured to operate as one in terms of identity management. Hence, single sign-on has been configured at the level of OAuth 2 and OpenID protocols. This does not mean that single sign-on holds for every type of user. Having security in mind, utilities managing different variants are not able to interact with other variants installations, even in the same region. High availability. The Catalyst marketplace variants, components, and architecture are following a microservices-oriented approach and have been designed with flexibility in mind. Further, Marketplace as a Service bases its operation on the industry-standard Kubernetes platform and can be configured to scale according to the available deployment nodes, having load balancing natively integrated into the design of the solution. Hence, even if one deployment node is failing, the service may be up and running in other nodes, no downtime being apparent to the users. Industry-grade monitoring of the Catalyst marketplace. The deployment being based on Kubernetes, metrics related to the component's health get automatically measured and served via interactive graphs based on Grafana. Ease of discovery. Since the deployment is automated, the exposed services, that is, the access manager, the information broker, and the multi-energy marketplace orchestrator, follow always the same endpoint URL conventions, so they are easy to discover. How it works. When a new variant deployment is performed in a region with no other deployed variants, then a new OAuth 2 project gets configured alongside a new Kubernetes namespace. Then The core shared regional components get deployed, that is, the access manager and the multi-energy marketplace orchestrator, and they are appropriately configured. Note that for reasons of segregation, each region gets their own Kubernetes namespace in order to avoid region interconnections. Next, the variant-specific OAuth 2 elements, that is, scopes, permissions, etc., get configured and passed to dynamically deployed instances of the Catalyst Marketplace components. If a new variant gets deployed in a region that already supports one or more variants, then only the variant-related settings get configured together with the deployment of the variant components. This makes the deployment of new variants really quick and with minimal configuration issues. The picture shows the deployment of an instance of the electricity marketplace on the Marketplace as a Service user interface. The deployment may be performed in a configurable, guided manner where all fields are dynamically populated. The Marketplace as a Service also exposes its own API so that the marketplace operators may implement their own user interfaces if they deem necessary. The picture shows a snapshot of the Marketplace as a Service Kubernetes deployment. Marketplace as a Service is also hosted in a Kubernetes environment and is also managing it to deploy the various Catalyst Marketplace variant instances at the same time. Each region gets its own namespace, so all Marketplace regional deployments are completely segregated. The picture shows the main technologies used in the Marketplace as a Service. Kubernetes is used for the coordinated deployment of the Marketplace instances. Django is used for the implementation of the Marketplace as a Service API. Vue.js is used for the generation of the Marketplace as a Service user interface. Grafana is used for the monitoring dashboards of the deployments. Prometheus is used for storing and serving the monitoring data. Keycloak is used for implementing the authentication and authorization mechanism. Celery is used for ending tasks asynchronously. A specific marketplace deployment can be accessed via the Access Manager. In order to proceed with active participation in a marketplace, a market session has to be created. Thus, the marketplace operator logs in, clicks on Admin menu on the navigation bar, selects the Sessions tab and clicks on Generate an Active Session button. A pop-up window with options to set up the new market session appears. The pictures show the creation of a new session in the electricity marketplace intraday. Registered market participants granted with rights to participate in the electricity intraday marketplace can access the created market session. Offers, bids, can be posted by clicking on the Add Offer Bid button. As represented in the picture, a pop-up window with options to create the offer or the bid appears. The offer or the bid needs to successfully pass the validity checks, ensuring that market session rules are not violated. In the Catalyst multi-carrier marketplace, before the end time of parallel market sessions has passed, the market participant is enabled to bind the actions placed in different marketplaces with strong, all or nothing, or weak, at least one constraint, from correlations, create correlations. Market correlations related to active sessions can be viewed from correlations, view active correlations. After the market session and time has passed, the session status is set to closed and no actions can be posted anymore in this session. The market is cleared and the market participant can visualize the results for their market actions from History menu. Finally, invoices are generated and presented to the corresponding participant. Each entity involved in transactions may access only their own invoices under the Invoices menu. All Catalyst components are available on the H2020 Catalyst group of GitLab under Releases. Installation instructions are provided as README files. Developers are urged to test and extend the code. Interactive Online API and error handling are supported and can be tested via Swagger. Catalyst Docker images can be found in Docker Hub under the H2020 Catalyst profile. Thanks for your attention.
Well, that was a very in-depth review of the Catalyst marketplace, and I'll now open the floor for questions. If we don't get any questions, I will do a brief closing statement, and then if anybody is watching this on recorded video from our website, then ping an email to the catalyst-info@project-eu address. Okay, so we haven't had any questions at the moment. I shall continue with the closing statement. Right, we have another 2 webinars scheduled. Next week, it's the Catalyst pilots. This is an overview of the pilots as described by Diego in the first video, where we tested the various scenarios of energy flexibility, heat reuse, and the migration of IT loads between Catalyst federated DCs. That's at the same time on the 9th of September. And then finally, on the 16th of September, we will be officially launching the Green Data Center Assessment Tool and the Roadmap website. And that is available for a soft launch at the moment on the URL roadmap.project-catalyst.eu. Thank you very much for participating. We hope forward to see you again and have a great afternoon. Thank you very much.